All right, we're talking about rational functions or rational functions and radical exponents. No, rational exponents and radical functions. All right, whatever. So basically solve these equations. Well, whenever you have an equation like this, 3x to the fourth plus 5 equals 248, you'll notice that you only have one x term. It's x to the fourth, but you only have one of them. And anytime that happens, you can solve this by isolating it. You can isolate the variable.
So we would subtract 5.
Good. Subtract 5 from both sides. What do you get when you subtract 5?
243.
Good. And what's 243 divided by 3?
It is 81.
81. And now the way that you solve this is you take the fourth root of 81, kind of like taking the square root, but you're taking the fourth root of it. And what is the fourth root of 81?
Wait, I know it. Is it 4? No.
It's 3.
3. Okay.
It's 3, but it's also negative. It's also negative 3.
Yeah, so plus or minus 3. Okay.
Yeah. So you understand why you have to put a plus or minus 3 here?
Yeah.
Because an even root, there's two roots for an even. There's always 2 roots for an even root because a negative times a negative is a positive. So think about it. If it was x squared equals 9, you know that x can equal either positive 3 or negative 3. It doesn't just equal positive 3, right? So you have to remember that when you're doing those. All right, so this problem, the rules for exponents are when you're raising an exponent to a power, x to the, actually, no, let's see, what do they write? B to the x to the y equals b to the x times y. That's one of the properties that you will see. I don't know how your textbook writes it, but what can I do with these two exponents here? Look at the rule I just put over there. What does it tell you to do when you're raising a power to a power?
Add them together or multiply them together.
Yep, don't add them, you multiply them.
Yeah.
So that would mean what's 4 times 1/6?
4/6.
Good. And can I simplify that at all?
Yeah, to 2/3.
That's right. Whoops. X to the 2/3. Now you could also, just so you know, you also could write this in a couple different ways. You could write this as x squared to the 1/3 power, which means it's x squared. It's the cube root of x squared. You follow that?
No.
So these two things are the same. You're going to have to know that soon. You could also write this as x to the 1/3 squared. And x to the 1/3, like I said, is the cube root of x squared. So all three of the ways that I wrote this are all possible ways of writing it.
Yeah.
Actually, all 5 of those are the same.
I should put the x to 2/3 though, right? It's probably what she wants.
Well, for now you should, but when you talk, didn't you say that you're doing rational exponents or radicals?
Rational exponents and radical functions.
Yeah. So this is a rational exponent right here, but this is a radical. That's how you write it, like a radical. So another rule that you have is b to the 1/n is the nth power of b. Those two things are the same.
Okay.
And that's kind of what I'm telling you. So another rule, if you have b to the x times b to the y, it equals b to the x plus y. That's another one of your rules. You should have all these rules, by the way, written down somewhere.
Okay.
Your teachers, I'm sure your teacher's given them to you. And if not, just jump on YouTube, on Google, and find them.
Yeah.
Write properties of exponents and you'll see a list of 10 or 15. Okay. So what does that mean I can do? What can I do with this? X to the 1/4 times X to the 1/3. What do I do with them?
You add the exponents.
Good. Now, are you good at adding fractions?
No.
Okay. So let's do this off to the side. 1/4 plus 1/3. The key to adding fractions is you have to have common denominators. And so the least common denominator is 12. So if I multiply this by 4/4, and if I multiply this by 3/3, I'll get 3/12 plus 4/12. And now they are both in terms of 12. They're like terms, so to speak, right? If you had 3/12 of a pie and 4/12 of a pie, how many twelfths of the pie do you have?
7/12.
Exactly. You understand why you need to put them in? I'll do a quick little review for you. If I took a pie and I cut it into fourths, and I took that same pie and I cut it instead into thirds, that's not a good third. How could I make that pie? How could I split that pie up among 12 people?
Gotta make it smaller.
I'm sorry.
Make
How
smaller
could I split
pieces.
that pie up among however many people I wanted to? I need to cut it.
Yeah, you need to make it smaller pieces.
Yeah, I need to make smaller pieces. So I didn't explain that very well, but you get my point.
Yeah.
All right, good. So this next one, we have 8/27 to the negative 2/3 power. All right, so this is like what I was just talking about. So negative 2/3 power, there's a couple rules at play here. If you have a over b to the x power, that's equal to a to the x over b to the x. In other words, you can distribute it to both of them.
Yeah.
So that's the first thing. So but there's another rule at play here. If you have a number to a negative power is the same as flipping it to the opposite side of the fraction bar and making it a positive power.
Mm-hmm.
So I can put those together and I can say a over b to the negative x. You know what that does? It flips b and a and it puts it to the positive x. That's another property.
Yeah.
So what I can do with this is I can flip it, and I prefer to do this. I prefer to deal with the negative powers first. I'm going to flip it, and then I'm going to make it a positive 2/3. That make sense?
Yeah.
Okay. Now, you remember the other thing I told you could do when you have 2/3? You remember how I told you can take it and break it up into 2 times 1/3?
Oh, yeah.
Right? So this is equal to 27 to the 2 times 1/3 over 8 to the 2 times 1/3. So I can actually choose which one of these I want to do first. Do I want to square this first, or do I want to take the third power first?
The third power.
That's right, because it's a lot simpler to do, right?
Yeah.
What's the third power of 27?
3.
3. Very good. So this equals, so I'm going to rewrite this 27 to the 1/3 squared. And I'm going to do the same thing with the bottom, right? 8 to the 1/3. Whoops. 8 to the 1/3. Got it? Squared.
Yeah.
So
Okay.
like you said, this is 3 squared. And what's 8 to the 1/3? What's
2.
the cube root of 8? 2. Good. 2 squared. So this just equals 9/4.
Yeah. Okay.
So lots of steps to that one.
Mm-hmm.
But it seems like you followed it pretty well. All right. X times y all over x to the 2/5 times y to the negative 1/2. So we're going to have to do lots of the properties here. So here's another property. If you have b to the x over b to the y. What do you do with x and y?
You multiply them?
Nope.
Do you add them?
Nope, you wouldn't add them because they're being divided. When you're dividing, what do you do with them? You subtract
Oh, you
them,
subtract, yeah.
okay?
Mm-hmm.
So this equals, so we can actually do it like that. We can say, notice this x and the y on the top are both to the first power.
Mm-hmm.
So I'm just going to write it out like this. So this is like x to the 1 minus 2/5. Got that?
Wait, so
And we'll simplify that in a second.
okay, yeah.
I'm just applying this rule over here
Yeah.
to the x's. Now let's apply it to the y's. What would y be? Y to the what power?
Y to the first minus 2/5.
No,
Or
y to
minus
the
1/2.
first minus what?
1/2.
Minus 1/2
Negative
or
1/2.
minus a negative 1/2?
Yeah, negative 1/2.
So minus a negative is what?
Plus 1/2.
Plus 1/2. You understand that?
Yeah.
So make sure you don't make that mistake. You got to be careful with those negatives. So this equals, what's x to the 2/5? Again, let's do the math over here. What's 1 minus 2/5? Are you good with that? Can you see it's 3/5, or do you need me to show you why?
I need you to show me why.
So 1, let's put it, what's the common denominator? Least common denominator?
5.
It's 5. So I have to multiply this by 5 over 5.
And then just 5 minus 2. Okay, yeah.
You understand that?
Yeah.
Okay. And then what's 1 plus 1/2?
3/2.
Good. And again, you could do it like this. You could do 2/2 plus 1/2 equals 3/2. Or if you just know it, you can look at it. Sometimes you can just look at it and you know what it is. Good job. All right. Let's see if we can apply all the rules to this one. We've got 7/3. We've got 4/3 raised to a negative 1/3. What's the first thing I should do?
You distribute the negative 1/3.
Remember what I told you I like to do first? You can do that, but remember what I told you when you have a negative power?
You can swap the A and B.
Exactly, flip them. Let's call it 4/3 over 7/3. Is that 7/3 or 7/2? I can't really read that.
I think it's 7/3.
Okay. To the what power?
So the 1/3.
Good. And now what do I do?
Now you can find the cube root of them.
Remember,
Or
what's the rule?
do you
What do I do
distribute
when I'm
now?
Yep, I'm putting it there and there. And what do I do with them? Add them or multiply them?
You multiply them.
Good. So what's 1/3 times 3?
1
Good. So this is just 4 over what's on the bottom.
over 7.
Done. Got it.
Yep.
All right. You want to find some more?
Yeah, we just went through those really quickly. Okay.
Yeah. And I can slow down if you need me to, but you seem to be
it's
getting this
fine.
pretty good. Yeah.
So there's here. I can write it out.
You can tell me and I'll write it out.
56. Oh, it's
56
it's in parentheses. 56 1/4
to the 1/4.
Yeah, to the 1/4 over 7 to the 1/4, and then outside the parentheses, the exponent is 5.
Like that?
Yeah.
Okay. And what do they want you to do?
It just says all of the rules are applied in the same way for rational exponent. I think it just wants me to solve it.
Okay. Well, first of all, since these are both raised to the 1/4, can't you rewrite it like this? 56 over 7 to the 1/4?
Yeah. And then
Yeah, and wouldn't that be nice? Because what's 56 divided by 7?
7
Not 7.
or 8.
So this would just be this would just be 8 to the 1/4 to the 5th.
Okay.
Now, this is a little bit trickier because 8 is not a perfect fourth. It's not like a power of 4. It's a perfect cube, right? 2 times 2 times 2 is 8,
Yeah.
but it's not a perfect fourth power. So your answer probably is just 8 to the 5/4. That's probably the answer that they want you to have.
Okay.
But technically, let me go a little bit further, because like I said, anytime you see a power, you see how 8 is a power of 2?
Yeah.
8 is, you could really rewrite 8 as 2 to the 3rd to the 5/4.
Oh, okay.
Now
Like
that doesn't
simplify it.
make it any simpler. That doesn't make it any simpler, but you could write it that way.
Okay.
And then you can multiply the 3 and the 5/4, and you would get 2 to the 15/4. And again, that's not any simpler than 8 to the 5/4. So this is probably the answer that they want.
Yeah, I
But
think so.
technically, this is the most simplified version of it.
Okay.
Okay, make sense?
Yeah.
All right, give me another one.
In parentheses, negative 2x squared. Y, and then the exponents to the negative first over x to the negative third. And then outside the parentheses, the exponent's 3, all cubed.
Okay, like that.
Yeah.
Okay, tell me what to do first.
We can distribute the 3.
You could, but usually it's easier if you first simplify what's inside. You see how I can
So
simplify that a little bit?
yeah, you could
What would I
subtract.
get?
You could subtract the 2 and the negative
Mhm.
3. So it'd be negative 2x minus 1.
Hold on, you gotta be careful. What did you just say you do with the 2 and the negative 3?
It's negative 2x plus 5.
Not
Or
plus 5,
to the 5th. Yeah.
right? Negative 2x to the 5th, good. Y to the negative first. You see why I didn't want to distribute that 3 in yet?
Yeah.
Now that when I distribute it in, I won't have to mess with those x's on the top and the bottom anymore.
Mm-hmm.
So what does that equal? Now be careful. You have to distribute it to all of these. This,
Yeah.
this, and this. Do them one at a time. What's negative 2 to cubed? What's negative 2 cubed?
Is it?
Think of it like this. Think of it as negative 2 times negative 2 times negative 2.
So negative 8.
Good. Negative 8. X to the
15th.
Okay.
And y to the negative third.
Good. Now, a lot of times the book will tell you write it with positive exponents. Does your book tell you that, or do they want you to leave it like this? Okay, so then remember what I told you about this negative power?
Just bring it down.
Yeah, but it goes down to the bottom. So this equals negative 8x to the 15th over y to the positive 3.
Okay. Yeah.
Good.
Mm-hmm.
Let's do another one.
How about parentheses x minus 3 where'd it go? Oh, here it is. And then outside the parentheses, it's like cubed, x minus 3 cubes, and that equals negative 64.
Okay, this is a different kind of problem.
Yeah.
This they want you to solve, not simplify. Right?
Yeah, it says solve each equation.
So to do a problem like this, how do I undo a cube? Remember we talked about before?
You cube both sides.
You cube root both sides.
Cube root both sides, yeah.
which means the 1/3 power, right?
Mm-hmm.
That's what we're doing. So then on the left side, I'll just get x minus 3. And on the right side, what's the 1/3 power of negative 64?
It would be negative. Um, -4.
Good. So here's a good thing to have. This is a good thing to have memorized. I'm going to put this at the bottom. Perfect
Yeah.
squares. Perfect squares are 1 squared is 1. So look, if I write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100.
Mm-hmm.
Right? Perfect cubes are also good to have memorized now. 1 cubed is 1, 2 cubed is 8. I'm multiplying each of these things by another number, right? By that number again.
Yeah.
27, 64, 125. What's 36 times 6? 216, I believe.
Yeah, 216.
And then probably that's what's 49 times 7?
343.
There you go. What's 64 times 8?
That would be
256 or 512?
yeah, 512. And then the other one is 729. 1,000. Yeah.
Okay. So those are good. I mean, probably up to here are good ones to have memorized.
Yeah.
Definitely up to here. So when you see that, you're like, oh yeah, that's just -4. And now what can I do to solve this?
You can add 3 to both sides.
Good. What do I get?
X equals -1.
Perfect. And then check it to make sure, right? Plug in -1 and see if you get it. -1 minus 3 is -4.
-4.
-4 cubed is -64.
Okay.
Got it. Want to do it? Got time for another one?
Yeah. So parentheses 2x minus 1. That's all to the 4th power, and then equals 625.
So I bet you 625 is 5 to the 4th,
Yeah.
right? You see what I'm doing here?
Mhm.
So what am I going to do?
You would
Take the 4th of each
yeah,
side,
the
right?
4th,
Take the
yeah.
4th power. So what's my left side of my equation going to be?
2x minus 1,
Mm-hmm.
and then equals 5.
Mm-hmm. Now hold
And
on.
then-
This is where we have to be careful. This is, remember, because it's an even one, you have to write plus or minus 5.
Oh yeah.
Do you
'Cause it
remember
could be
that?
negative. Yeah, because it could be -5.
Exactly.
Like,
So whenever
yeah.
it's an even root that you're doing, you have to include the negative as well as the positive. So you're actually
Okay.
going to have 2 solutions here. So 2x minus 1 equals 5, and 2x minus 1 equals -5, and solve each of them separately.
Mhm.
So what is this one on the left going to be?
Oh, 3.
2x equals 6, x equals 3, and 2x equals -4, right?
Yeah.
X
So then,
equals -2. And again,
Mhm.
let's check them, plug them in. If you put a 3 in here, what's 3 times 2?
6,
6 minus 1?
5,
Perfect. What's 2 times -2?
-4,
Minus 1?
-5.
Perfect. Okay, got it?
Yep. They
All
look
right.
intimidating, but they're not. They're not hard.
Yeah, I mean, they can be, right? Because you have to, there's a lot of little tedious details of all these, but these are the ones where you just have to practice, 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 practice.
Yeah.
We probably have time for one more. You want to do another one?
Yeah. Let's do this one's back to the ones we were doing. So in parentheses, 6 to the two-third power, and then all times 1/2
To the 1/2 or times 1/2?
to the 1/2.
Okay. So to the 1/2, what do I do with the exponents?
You add them.
Oh, so these are
Oh, you
these are,
multiply them.
remember, yeah, you have to multiply them. Make sure you get those things, you have those things written down somewhere.
Okay,
Okay.
yeah.
Get them written down, because your math is good, but if you don't know the formulas,
Then I just can't
you're
do
going to
it.
be in trouble.
Yeah.
So, and how do I multiply? Here's the other thing for people. How do you multiply? Is multiplying fractions easier or harder than adding fractions?
Easier.
It's easier. But let me show you a little trick. Don't ever just multiply them straight across. And because you could have probably more easily simplified it first. You see how they both have a 2?
Yeah.
So 1/3 is your answer. If you multiplied them, you would have gotten 2/6, and then you'd be like, oh wait, that's 1/3. Instead of multiplying them, cancel them first, and then you'll have less likely to make an error with that as well.
Okay. I never noticed that.
Yeah, just canceling factors. Simplify. I always say to people, simplify before you